So today we're going to talk about NOIR as a mnemonic for levels of measurement. So think of NOIR, N-O-I-R, as an acronym as we go through this. You then might also ask yourself, what exactly is a mnemonic? A mnemonic is a fancy term for a kind of memory aid. Something that helps us recall some kind of information, right? So mnemonic is pronounced like demonic, but with the N in place of the D, and there's also an M thrown in there in the beginning, but the M is silent. So what are some examples of mnemonics that you might have already become acquainted with? Well, there's one, I before E, except after C, so that's a common spelling rule for lots of people that have had to learn English, right? But it's actually a flawed spelling rule. If you want to look up cases where it doesn't hold, use your friend Google, right? But in the meantime, I still recall this every time that I have to write niece. So I before E, except after C, right? What else? Well, what's another example? Red skies at night, sailor's delight. So maybe you've heard this because you have some relatives that have been in maybe the merchant marines, or they were pirates, or something like that. Maybe they are atmospheric scientists or climatologists. So red skies at night, sailor's delight is sort of a weather heuristic. So it's a way to read weather patterns and make some kind of prediction about what the weather is going to be like, right? So this, when you have red skies at night, the weather will be delightful for sailors because there won't be big storms or massive winds that sink their ship, sending them off to Davy Jones' locker, right? Another mnemonic that you might have learned is bedmass, or bedmas, as some people might also say. This stands for brackets, exponents, division, multiplication, arithmetic, and subtraction. So this is to help you recall the order of operation for a particular kind, or I guess the order of particular kinds of mathematical operations. So we do everything in the brackets, then next we do the exponents, and then next division, then multiplication, then arithmetic, and then subtraction. All right, so those are some examples of mnemonics. If we recall back to the beginning, we were thinking about NOIR as a mnemonic for levels of measurement, or a level of measurement. Well, what is a level of measurement? A level of measurement refers to the kind of data one has. So this could be nominal, ordinal, interval, or ratio. So there's 4 levels of measurement. There's nominal, ordinal, interval, or ratio. Some people will call this also a measurement scale. And you'll see here in many of the fine Space Inc. films, especially those geared towards education, you'll see AKA, which is an abbreviation for also known as. So now we come back to what is NOIR? What does this mean? So NOIR is a mnemonic to help you remember the order of the 4 levels of measurement. So the 4 levels are nominal, ordinal, interval, and ratio. So a way that I always think of this, which I'm not sure if it really works for everybody else, but for me, I always think of film noir. So this was a particular kind of film genre that isn't shot a whole lot anymore, except in sort of a retro sense. It was popular in the 30s and in the 40s, and in film noir, evidence played a pivotal role in these very dark, or noir in French. So dark is noir in French. In these very dark films. So the Maltese Falcon is sometimes suggested as an example of this. M für Murder was a German one, so M for Murder, which is about a sort of psychopath who went out and murdered people, and this was a particular, I guess all psychopaths do lots of different things, but this one really got into the psychological aspects of this demented person who appeared on the surface to be a sort of upstanding Bürger, so this sort of upstanding middle class person, if I recall correctly at least. So I'm sure you can email me if I've gotten that wrong. But so I think of film noir, right? And then I attach that somehow to noir as this mnemonic. But, attach it to whatever works for you. And this mnemonic works for me because NOIR deals with nominal, ordinal, interval, and ratio levels of data. So now let's talk a bit about what do I mean when I say nominal levels of data. So nominal is derived from the Latin word for name, nomen, or roughly pronounced that way. The important feature of nominal data are that they are unrankable. So, an example, in this series of films, I tend to use red boxes to hold examples. So, some examples of unrankable data might be if we're referring to either sex or gender, depending upon the kinds of theoretical framework you're coming from. We might say that people fall into the category of male, female, or other. So, we think in terms of sort of the someone's physiology. So, we might think in terms of pets, in terms of common sorts of pets in North America are things like cats, dogs, hamsters, ferrets, and goldfish, right? If we think in geologic terms, so if we think of the various sorts of rocks and the way that they are formed, a classification scheme, very crudely used in geology and also in physical geography, looks at igneous, sedimentary, and metamorphic rock, right? So that those are the three major kinds of rocks, and then you can break them up some more from there. But it's really hard just on the surface to say that any one of these is superior to the other. So that's really the key feature of nominal data. That it's intrinsically the data are unrankable. So with regards to pets, we could rank them by weight, but that's really comparing weight of pets. It's not just talking about the pets as sort of pets in and of themselves, right? Ordinal data refers to data that can be ranked, but the interval or distance between each rank is not uniform. Ordinal level data can be ranked, but the interval or distance between sort of each rank is not uniform. So as you progress from, say, 0 to 1, 1 to 2, 2 to 3, those distances between those numbers don't really refer to anything that's measurable in a uniform sense. Here comes an example. So Likert scales are the prime example of ordinal data. If we think of income, we could say that someone would be placed in a high income category, a medium income category, or a low income category. And the sort of the distances or what you had to do to fall into those categories, the amount of money you had to have might not be the same. So for instance, low income could be like $0 to $20,000, medium income could be $20,001 to $100,000, and then high income could be $101,000 to an infinite amount of dollars. And so those distances between those three categories are not equal. Satisfied, neutral, unsatisfied. These are examples that you might often see on a Likert scale. So some people might set up a survey in which they ask, are you satisfied with how would you rate the level of service at this restaurant? Overall, would you say that you are satisfied? Overall, would you say that you have a neutral level of satisfaction? Or overall, would you say that you are unsatisfied? We could rank hair. So does somebody have long hair? Does somebody have medium hair? Does somebody have short hair? Do they have no hair? It really depends on a lot of cultural factors. What one person could call medium hair and another could call long hair could get a bit messy. What somebody calls short hair and what somebody else calls long hair could blur together. And that's one of the problems with ordinal data, is that sometimes the data can be replaced by a superior kind of data. And that would be superior in the sense that the distances between each level or the distances in the ranking are uniform and can be measured. So, interval level data. So interval level data can be ranked, and all of the intervals have equal width. So two really common examples. Well, let's get to those in a minute. A thing to recall with interval level data is that 0 is just a placeholder. It doesn't represent an absence. So if, for instance, it's 0 degrees centigrade outside, that doesn't mean there's an absence of heat. It just means that that's sort of an arbitrary point on the Celsius scale. Likewise, Fahrenheit, 0 degrees Fahrenheit, is colder, but it still does not represent the absence of heat. So, common examples then for this are really Fahrenheit and Celsius temperature scales. So, they're interval level data because 0 does not equal the absence of heat. And off the top of my head, I would say that interval level data are actually not very common. What's more common, I would argue, or sort of based on my recollections, as I sit here narrating this, what's more common is ratio level data. So ratio level data can be ranked. They have intervals of equal width, and 0 indicates the absence or the lack of the thing being measured, right? So what's a good example? Weight is an excellent example of this. So I really can't weigh 0 pounds, right? So I suppose I could stand on a scale that only measures weight in tons. So let's say they're metric tons, and I could stand on a scale that measures weight in metric tons, and it's possible it would read essentially 0, but that's more of an instrumentation problem. I still have a weight, right? So not having a weight tends to indicate the absence of having weight, right? So that's sort of, I guess, metaphysical. We don't really need to go into that. Let's go to some more examples. So length, or height even. So we can think of the length of something. Something is 5 meters long. If it's 0 meters long, that dimensioned length just doesn't exist. Income. So I could have income or I could have no income. This is a state that we can find ourselves in, right? So I could be unemployed, have used up all my benefits, and be in a situation where I draw no income whatsoever, or I could have some income like $500 a day or what have you, right? So but these are some examples of ratio level data. In all three cases, weight, length, and income. In these three examples, 0 indicates the lack of something.